there, and welcome to the Mat 211 review of matrix multiplication. My name is Julia, and I work for the tutoring centers at ASU. So today's problem is a word problem. Suppose store A sells 300 sodas and 250 lemonades. Store B sells 100 sodas and 50 lemonades at the same price. Further, a soda sells for $3 and a lemonade sells for $2. Use matrix multiplication to find total revenue for store A as well as from store B. So, what do we have here? We know that store B we know the price of our two drinks, and we know the quantities of each drinks for each store. Now remember that revenue equals quantity times price. So we're going to use this little bit of knowledge to figure out our revenue for each of the stores. So for instance, if we want to know the revenue due to soda from the first store, store A, it would be the number of sodas, 300, times the price, $3. And if we wanted to know the total revenue, we would also add on 250 lemonades times the price of a lemonade, which is $2. And that would be the revenue from store A. Now it's helpful to know how we're calculating this because this will help us build our matrix multiplication equation. So we know that since there's two stores, we know that our final matrix is going to be some matrix with 2 rows and 1 column. So 2 entries, 1 for each store. Now, let's think of how we can get there. So recall that, well, first, let's build this from, our solution, and we'll build it backwards to give us our matrix multiplication in this case. So again, we know that 300 times $3 plus, 250, not 100, 250 times $2 is going to be our total revenue for store A. Similarly, we have 100 for our sodas times $3 plus 50 for our lemonades times $2 for our revenue from store B. So we can treat the price for each of the lemonade and the soda as what you would say is your variables. Kind of like if you had A times X equals B, where this is our B, we would think of these two price points as our variables, our X's in this case. So let's go ahead and put those in as a 2x1 column here, or 2x1 matrix. So we'll have $3 and $2. Now we want to think about the coefficients, or the coefficient matrix, the A matrix. How would we build that? So whenever we do this, we're going to have 1 row for each equation. So, revenue of store A is going to be one equation, and revenue of store B is the other equation. And each one of those would multiply. So if we had a row here, this would multiply with our column here. So we can treat sodas and lemonades the quantities from store A as the first row. And so we'd want to make sure we line them up correctly. So 300 sodas, that's going to be the first element here, because it's going to multiply with the first element of our column, our X. So we can think of that. So let's put our 300 in that first row, first column slot. Similarly, the 250 here for lemonades, that's going to multiply with our second element in our X matrix. So we would want to put that in the first row, second column spot. So 250. And then our second row is going to be store B. So if this is A, this is B. So we can do just the same thing, start with our sodas, because we know the first element has to be a soda to multiply with our 3 here. So that's going to be number of sodas. And lastly, 50 lemonades, so that it multiplies with our 2 here. So sometimes it helps to understand what our final product looks like so that we can set up our matrices accordingly. So if we go ahead and solve through this, first of all, note that we would have 300 times 3, which is that guy, times 250 times 2, which is that guy. So that works. 100 times 3, there you go. And 50 times 2, again, is going to be our 50 times 2 over here. So we've got this set up correctly. Now it's simply a matter of doing the arithmetic in this solution column or solution matrix to get our final revenue for each store. So if we multiply through the first row, first column entry here, we get 1,400. And the same is actually true if we multiply through our, well, actually, no, excuse me, the same is not true. We only get 400 for the second store. So remember that since we started here with our store A as the first row, our value for store A is also going to be the first row. So this is revenue for A. And similarly, this is going to be revenue for B. And that's it. So that is our final answer. And once you get used to kind of the strategy behind this, you won't need to find the solution before setting up the matrix. So thank you so much. Let's clear that. Before I go, I just want to remind you all that if you are looking for any additional academic support or tutoring at ASU, you can go to the following link, tutoring.asu.edu, to see all of the tutoring center's different resources. Similarly, if you are looking for tutoring services for a specific course, you can go to the tutor search tool, which you can find both at the main webpage here or by going to this full link here. And the tutor search tool will allow you to find specific tutors and tutoring services for your course. So thank you so much and have a great rest of your day.